Hello everyone, welcome to the channel. So in next video in this series of data structure and algorithm for the sorting algorithm, we'll have a look into the quick sort algorithm and we'll learn the algorithm, we'll do the try run and we'll write the program. So in quick sort algorithm, basically it's similar, very much similar to the last algorithm we read and we studied the algorithm and program. So it's also based on the divide and conquer approach where we usually divide and at the end we just sort those elements and we provide the result of our algorithm or we provide the sorted array. But in quick sort, basically we usually take a element, we call that element as a pivot element, and with that element from that specific array that we got or provided with the array, we divide that array into specific sub arrays using that pivot. So pivot is basically a kind of central point, or we consider it as a central element. So let's see. Okay, so pivot is a basically central point or the central element. So we need to remember these 2 points. The first point is pivot. Okay, and the second point here is partition. Okay, so we will basically use these two things, first pivot and second partition, in our quick sort algorithm. Okay, so we basically use pivot in multiple ways. We can use pivot in multiple ways. Either of that is we can use pivot as the largest element, not the largest, sorry, the high end of the array. Okay, or we use pivot as the low or starting of the array, or we can use pivot as any central point. Okay, but in most of the cases we consider this first point, so we consider pivot as our last element in array. Okay, so we consider pivot as last element in the array, and using this element we keep dividing the array. So I take this pivot element, and using this element we divide into left and right into two parts. So if element less than pivot, it will go to the left hand side if the elements are smaller, and if the elements are higher or greater, then it will go to the right hand side. Okay, so we keep on dividing the left and right subarrays using this same approach without until not the until each subarrays contains only a single element. So we usually take like I told you, pivot as the highest or last element of the array. So using an example, let's see the quick sort approach. So I have taken an array here, and let me just write the elements. Okay, let's just take one here, 8 and 2 4. So I consider the last element, like I have told you, we will consider last element as the pivot element. Okay, and we consider this element as, you can see, the SP, secondary pointer. With this element we will always do our comparison. Okay, so some take this element as a pointer, secondary pointer I or j in the program. I take usually this as the secondary pointer. because pivot is our most important element. Also this element is our most important because using this element we will do the comparison. Okay, let me also write up the index up here. So in my first case I will compare my pivot. So the condition would be secondary less than pivot. If this condition is true, then make a swap. Okay, so here I can see 3 is less than 4. Yes, we have to swap, but there also come a condition in this uh, quick sort. Let's suppose after in this comparison thing, if current element is smaller than the pivot, okay, then we swap the smaller one, okay, with the that specific pointer and increment this secondary pointer to the next index. But in any case, like in this case, like 0th element or the starting element is smaller than the pivot, then we will not do the swap, we will do the swap but on its own position. So this element is small, okay, my condition is true, then I will just only do the swap at its own position and I will just increment my SP secondary pointer. Moving forward, I will be here and my pivot is here. Now I will compare again. If 5 is less than 4, so this condition is wrong. We will move forward, but we will not increment our secondary pointer. Okay, we increment secondary pointer in only the cases where this secondary is less than the pivot element, then we do the swapping. But here I will not do the swapping. Okay, so my secondary pointer remains the same, but my condition or my loop will increment and it will goes to here. So 0 1 2 3 4 and 5. Now I will compare. Now is my 1 is less than 4. One more thing I forget to tell you, in quick sort the first thing that I am currently doing is comparison. Okay, so I'm first doing the comparison of my pivot with all the elements. Okay, in this first scenario I will only do the comparison. I will check with each and every element and I will place my pivot in the middle or central position. Like I've told you earlier also, the line that I consider pivot as the kind of central point. So in first case we will first just compare the pivot with each and every element. We will just do those swapping, and then when my pivot comes in between, then I will do then the partition that I have done, then I will just do the sorting for that thing. So the first case is comparison, and the second thing we are going to do is partition. Okay, now is my 1 less than 4? Yes, this is true, then I will be doing the swapping. But let's go to the first case that I have told you. In case of third, where my 3 is less than 4 but I haven't done the swapping. Why? Because my secondary pointer is in its own place. Okay, and my I or my loop is also in the same position. So I have done the swapping but at the same position. But now my secondary pointer moves forward and my loop also moves forward, and then I see my secondary pointer is still in the first index. So now I can do the swapping. So I have to do swap of 5 and 1. So my 1 goes to the first index. So after third case, my array looks like 3 1 5 8 2 and 4. Okay, now my secondary pointers comes here, my secondary pointers also increments here, and my loop is here and my pivot is here. Okay, SP is here, my loop is here. Okay, now I'll see, is 8 less than 4? No, I'll move forward to the fourth case. Okay, my loop also gets incremented, my secondary pointer is going to be remain same. Okay, 8 2 4. my SP is here, secondary pointer, my loop position is here, and my pivot is here. Now is 2 less than 4? Correct. So we will do the swap. Now we will just swap the 5 with 2. Okay. Now in my fifth case, my array looks like 3, 1, 2, 8, 5 and 4. Okay. My SP is here. My loop reaches the last or end of the array and my pivot is 4. Now after my loop reaches the end of the array, then we will come out of the loop and then we will just again do a swapping. Why? Because I have to return my pivot index. Okay, and I have to do the swapping. So I will swap my pivot with the secondary pointer. Okay, so in this case my pivot goes to the position of secondary pointer here, and 5 is going to remain same. Now this looks like my array. So my first case is completed, or my first thing in the quicksort is completed, where we are going to do the comparison. Okay, and now my second case start, where I will be doing this partitioning and then I will sort this array. So I have my 4. Okay, now I will just divide this into two part, 3, 1 and 2 and 5 and 8. Now this will be my pivot here and this will be my pivot here. Okay, now I will compare this pivot with 3, 1 and 2 and then I will just sort these elements. Okay, and these are already sorted, so in one go it will sort. Then after these two elements I will again just sort this element. I will just merge this array, not merge, I will just sort this element, because after partitioning this one is sorted, this one is sorted, and we are going to get my complete array. Okay, so this part and this part, so at the end of my loop I will be getting this array. For better understanding, let's go to our program and see what I am exactly telling you for the second case. So let's write our program. Okay, so we have just seen our algorithm and the dry run of uh, an array. Let's go to the program and let's open the IntelliJ and see how the code works. So let me just write the static void main. First I will be taking an array, the same array that we have created. First I will be taking an array, the same array that we have used for dry run. We will use that same array to write our program and then we will use that array to understand it. Okay, n will be my size, or I'll just skip this and let me just take one more function. I'll call this method and I'll just pass my value array, starting or lowest index is low, high would be array dot length -1, because I am starting from 0, so that is why I have -1 I have used from array dot length. Here in the quicksort function I will be writing my first condition. If my low is less than high, then only I will enter in this loop. So in any case, where low index value is less than the high index, then we will ignore, or we will consider it it's sorted one. Okay, so inside this we will first write our pivot index, and we will just use one more method, partition. Let's just write that method also, and with that partition I will be returning my pivot index. Here also I will be taking low and high, and let's suppose I will be returning, as of now I'm just returning 1 because my program will not throw the error. I'll just sort this thing. Okay, so inside my partition method I will be passing my array and low and high. Okay, so my first thing would be I need to do partition comparison. Then after this comparison and partitioning is done, then I will be sorting that element, and first I will be using this recursion here. So okay, so what we have done here in the QuickSort method, I'll just quickly explain you guys. Okay, so here what we have done, it will return our pivot index. Okay, it will return our pivot index, and let's suppose I'll be creating this array 3 5 1 8 4. Okay, I'm just ignoring that 2 as of now, or let's just write that 2 also. 2 4. Okay, so first what I will be doing is I will be doing the comparison of this, and whatever comparison or whatever uh, you know comparison I have done, and then the swapping I have done, then at the end I have to return the pi or pivot index, I can say. So using that pivot index, then we will just, let's suppose my 4 is in the center, then I will just divide my array. Okay, like I have told you, we are going to use the divide and conquer technique. So after dividing my array, then I have to consider these two. So my low would be same and my high would be pivot. So let's suppose this 4 is here, uh, these are like this 3 1 2 and 4. So my high would be low and pivot minus 1 because I have to consider this element. Okay, so pivot minus 1. Similarly here my elements are 4 5 8. So my high would be this, I know my high is this, but my low in this case would be pivot plus 1. So that is why these two conditions we have written and the values that we have written here. Okay, so we will be doing this recursion here. So first in this case we will first divide this also. Let's suppose here these are 3 elements. In any case the elements are like uh, let's suppose 3 1 2 0, or I'm just writing it 5 7. So again we are going to then divide these into 2 parts, then again divide these into 2 parts, then again divide this into. Okay, so that is why we are going to write the recursion here. Okay, uh, now coming back to our program. Okay, so coming back to my program, in the partition method what we are going to do, so first we are going to choose our pivot element. Okay, like we have told and we have decided that to choose pivot element there are certain conditions. Either we can choose the starting element of the array, or we can choose the ending element of the array. So in most of the cases we consider pivot as the ending element of the array. So here also I will be consider my pivot as the ending element of the array. Okay, afterwards we are going to consider the secondary pointer. So my secondary pointer would be low minus 1 or minus 1. Okay, so index of smaller element with which we do initial comparison, and that indicates the right position of pivot found so far. So we should usually take this as either of low -1 or -1. Now we will be doing the comparison. Okay, and at last we are going to return this I will be the index of my pivot element. Okay, so that is why we have taken this I also. Using this I only, we are going to make comparison with pivot. Now I will be running a for loop, and my j would be low and j less than high j plus plus. Inside this we are going to make comparison. If my array of j means my starting element is less than my pivot element, then okay, it's not arr, array of j, then I will just increment my secondary pointer to the next index, and I will be doing the swapping. So swapping will be, I will be creating an temp, and inside temp I will be pushing my array of I, and array of j would be not j, in I have to put. Okay, so first let me just write and then explain you guys. Okay, so in this case, if my array of j starting element is less than the pivot element, we are running a loop, then we will be incrementing our secondary pointer or I to the next index, and we will do the swapping. But like I've told you in first case, you know what we are going to do, we are only going to do swapping with itself only. Like my I is at 0. Okay, so array of 0 I will put in temporary element, and array of j is itself is 0, I will put in array of I, and temp in array of j. So in the 0th only we are going to persist with the same element. But let's suppose my first element is not the smallest one. Okay, it's the greater one. Let's suppose let me just do a better let me just write it up here. Okay, so let's suppose my first element is 8 less than 4. No, it's not. So my I will remain at 8. Okay, secondary pointer will be at in. Now moving forward, 2 is less than 4. Yes, it is. So I will do the swapping. So my elements are like, let's suppose 8 1 2 7 4. I'm just taking a different array for you guys to understand this condition. First case, 8 is less is okay, 8 is not less than 4, no swapping. Second case, okay, second case, 2 is less than 4, swapping. But my SP is here, secondary pointer, or I would say my ith is here, my loop, my j is here. Okay, and my pivot is here. Now I will do the swapping. Okay, I will do the swapping using this. 2 comes here, 8 comes here, and 7 and 4. Okay, now my I is here, and my j is here, and my pivot is here. Similarly, next condition, I will just do this swapping here. So it will be like 2 1 8 7 4. So this is the condition that I was talking about. Okay, now in any, let's suppose it is sorted now, like 2 comes here, 1 comes here, 7 comes here, 8 comes here, and 4 comes here. Okay, now my pivot is here, my secondary is here. Now at the end I also have to do return the my pivot. Then I will just swap its position and I will return my pivot. Okay, so let's see what I was talking about. Let me just delete this. Okay, now after this thing is completed, I will be doing I plus plus again, because I have to increment my I, and then I will be doing this swapping. I will take this temp, and inside temp I will just push my array of I, okay, the current one, and inside this array of I will put the pivot element. And you know, like I've told you, my pivot is at the end. So as usual, at the end or at the high, I will put the temp one. Okay, and then I will return my I. Okay, now for a better understanding of this, let's do a dry run of this. Okay, with this array only. Okay, let's suppose I have this array 3, 5, and 8, 2, 3, 5, 1, 8, 2, 4. Okay, let's just. Okay, so we have completed this program. Now let's just do a dry run of this array only for a better understanding. Okay, I'll just do some indentation here. Okay, I also need to print this. So for int error, and we'll run this array. Okay, main method is not found. Okay, oh, I think I just mistaken in this. Okay, so now it will run now. Okay, we can see our array sorted 1, 2, 3, 4, 5, 8. Now let's see the dry run of this. Dry run this 3, 5, 1, 8, 2, and 4. Okay, now first I will be doing this condition. So I will be going up here, and my pivot element is 4, my low is -1 in first condition, my j is 3, and if j compared with 4, yes, it is true, so j will be in its original position. I plus plus I is -1, so it will become 0. Array of 0, it comes to temp, means array of 0 is 3, it comes to temp. Array of j is also 0, it goes to I, and temp goes to j, so it will remain same. So it will remain 3 only. Now this is the first condition. Second condition, 5 is less than 4. No, so my I is here. Earlier it was here only, 0. Okay, now my loop now comes here, my I is here, my pivot is here. Okay, now I will just write this array. Yes, it will now check, is 1 less than 4? Yes, it is true, so it will swap with the last position, means my I is 1, it comes. Okay, array of 1 is 5, it goes to temp, so temp is 5. Now array of j is second. Okay, so array of j 1 goes to array of I. Now my temp is 5, it goes to array of j. Now my array becomes like this: 3, 1, 5, 8, 2, 4. Okay, so in this way we will just do comparison, and at the end our array would be like 3, 1, 2, 4, 5, and 8. Okay, now our first step is completed, the partition. Now we have to do the two step of quicksort, where we will be dividing our array into the two parts. So the first case, I will be taken my array. We have our array, low will be this 0, high will be this, 6. Okay, not 6, it's 5, because we have taken array dot length minus 1. Now my pivot index, I have returned my pivot index. So my pivot index is this 0 1 2 3. I have returned pivot index is 3. Now pivot minus 1, so 2. So the first array is this, second is this, 4 and 5. So first I will just sort this. My array goes like this, pivot now becomes second, and I will compare with this. Okay, so my pivot would be 2, my low would be minus 1 as usual. Okay, and I will be comparing these three, 3 1 and 2. So I will be comparing first, like, is 3 less than 2? No. Then I'll just go to the second. Is 1 less than 2? Yes. Then make a swap. 1 goes here and 3 here and 2 here. Then at the end, as usual, I'll just swap the position of my pivot and secondary pointer. It would be like 1, 2 and 3, and it's already sorted. Let's just clear some space. So now I have two array where 1, 2, 3, 4, 5 and 8. Okay, now after my second array I can see 5 and 8 are already sorted. So it's like array is 8 highest and lowest minus 1. So it will compare like, is 0 less than the high? So it will sorry, not this one, this condition. So my 5 is less than 8. Yes, it's there, but it's, we have already sorted. Okay, now my pivot goes to this element, and here this condition is as usual the same, because I will be just writing my 8 is at its usual position. I'll be just doing this swapping up here. So 5 8 here, these are like 0 1 2 3 4 and fifth, and not the fifth, 4 and 5. Okay, so we'll do as usual swapping to its own place, and at the end of this thing will return with 5 and 8 an array, and our array would be 1 2 3 4 5 and 8, and we will just return this array. So in this way we are doing the quick sort. We have taken a pivot element, and using that pivot element we first do the comparison, we do the swapping, and after swapping we just do the sorting of these elements. Now, so for now, for time complexity, for worst case works in big O of n square, and in average case it works in big O of n log n. Why? So these are the it's an important question in the interview, like why was like, out of the both algorithm, merge sort and the quick sort, which one to choose? So if we see, like, merge sort gives us the big O and log n, and quick sort is giving us, in the worst case, is giving us the n square. But the thing is, here we are not using the extra space. In merge sort we have seen that we are using an extra array to, first we are just dividing and then we are conquering, then after merging that array we are copying it in a different array, and then we are using an extra array to copy back to our original one. So that extra space is there, but here in the worst case we are getting big of n square. Why we are getting? Because in case of quicksort, where every time pivot becomes the smallest or largest element in an array, so at that point of time our worst case complexity comes, and worst case complexity in this case it becomes big of n square. That's it for today, guys. Thank you.